So in Chapter 13, Think Like a Computer Scientist, we're talking about how to save to files. Let's write out anything. It doesn't have to be, once upon a midnight dreary my file.write I ate a raven. Tasty. Okay. And then my file.close. It's not Edgar Allan Poe, it's an Edgar Allan Poser. There we go. So run it. And now we should be able to find that txt file. Just open up a Windows Explorer window, go to the same directory, the same folder where you save that script, and you should see t.txt. If you have to, sort it by details and then click on date modified to bring it up to the top, but there it is. Double click on it and there's our epic poem. Once upon a midnight dreary, I ate a raven. Okay, it's almost cool looking, but I would like to make an improvement. I don't like it looking like that. I'd want it to look like that. So unlike the print statement, the print statement goes to the next line. The write command doesn't. So we're going to put a /n, \n, the one above the enter key, not the one below it.
After the quotes or in the quotes?
Before the quotes, it's actually part of the data that has to be printed. If you stuck it after the quotes, very good question. Well, it's not showing it as an error, but I gather on T that when we run it, it's going to say unexpected character after blah, blah, blah. So this is what's known as the Newline character. It's also got a fancy special term, an escape sequence. An escape sequence is any special character that begins with a certain symbol. What that means is escape from your usual mode of processing, because now we're going to do something different. All right. I didn't make the term escape sequence up, and it seems kind of cryptic, but it's a special character that calls it that, and we've used /t, right? We use /t to do tabs. Maybe we haven't, but you can do /t, and it'll tab your data over. And there are other ones. It used to be that /g would make your computer beep, but I think a lot of languages don't support that anymore, because you could write an infinite loop that caused the computer to beep and then walk away, and your computer just sit there beeping until somebody unplugged it. Alrighty, so this thing, the fancy name for it is file handle. That comes from earlier programming disciplines and languages, like programming for Windows 3.1, where everything you access, whether you're drawing something on the screen or you're reading from the disk or you're trying to find out the mouse's position, is done through what's known as a handle. A handle is a pointer to a specific place in memory. So you still use that term, even though there's, okay, anyway, so that's what's known as a file handle. And once you have a file handle, you can open the file. Well, you can write to it, you can close it. What all can we do with it? Let's see if we can find a file Python methods. Methods are functions that act upon data. So let's go see what we can find here. There's close. There's flush. What flush does is data sometimes gets buffered. I'm not sure if everybody's familiar with the term buffer, but when you're reading data from a disk, I'm sure that you are more familiar with the term cache or cache, however you like to pronounce it. It's an intermediate layer of memory because reading from the disk drive is slow. The disk drive is, hundreds of times slower than your RAM. Flash memory is faster, which is why you buy solid state drives to put into your, your high-end laptops. But reading from a disk is incredibly slow. So that data gets put in to an intermediate state. So that if you call read, several times in a row, it doesn't have to go and get each piece of data. It'd be like if every time I wanted to write something to the file, I'd have to go down and write all the way down here at the end of the chalkboard, then I'd have to turn another name to write on the chalkboard. I walk all the way down. Instead, what I want to do is collect all the names, make one trip out there, write them all down, and then come back. That's called buffering, all those names that I'm carrying. So when you're writing to a file, the operating system is buffering it so that it can write them at one fell swoop when it feels like it, for efficiency's sake.
It's kind of like a temporary library.
Yeah, exactly. So, but if you call .flush, it makes sure it's saved, because you're not really sure it's saved until the file is either closed or flush has been called on it. I like the word flush. It sounds... I'm going to send my data. All righty. So there are read statements. There are next statements. There are seek. Seek is so that you can move yourself to a specific position in the file. Now, everything that we're going to do today is just assuming top to bottom, just like a typewriter roll, just like the screen. But you could actually tell it to go back to the beginning of the file and make a change. All right, I'm not seeing anything really awesome here to talk about. Let's get path to a file in Python. One little thing I want to do. It is a good idea to store your file name in a variable so that you could open the file several times in a row and not have to type that string in, and so that later on, if you wanted to change, the file name that it was saving to, you just have to change it in one place, or you could ask the user for the file name. So let's do that. We're going to do this. Print save to what file, ? And then we're going to do file name is equal to input. Then instead of opening t.txt, we're going to open what the user told us to open. Bless you. If we were really polite programmers, we would check to make sure that that file doesn't exist. Because, we could specify, the file name word.exe, and if we were in the right directory, it would erase Word, our Word application, and replace it with Once Upon a Midnight Dreary. I don't know if that's really what anybody would like. However, this is not checking for the file before it opens it and blasts it, erases it. So when you do some programming in the real world, you're going to want to take a little bit more care than what we're doing here. So let's run it. Save to what file? I don't know.txt. Now if I go out into my scripts directory, where'd it go?
Can you go into your search and look for it?
Yeah, I guess I will. I don't know.txt. Well, there it is. It wasn't showing up a minute ago. Don't know why.
Because computers are consistently inconsistent.
That's right. So there it is. There's my file with the file name that I specified. That file name could be what's known as a fully qualified file name. Fully qualified means that you specify the path. A path is something like this. This scripting directory that I've been saving into, here's its path. So if I wanted to save into that, I could do this. There's a couple changes I would have to make. Plus file name. like that. So we're prefixing it with a path. This could possibly save it into a different directory than what we're currently in. You know, if we change this to, you know, a different username, or we didn't want to put it in desktop whatever, then we would change all this. So that's what's known as a fully qualified path. I feel like giving it a shot, but the problem is that it's got these backslashes in there, which may make it think that those are escape sequences. Like, what if your directory was this? You had C:\/ users / ned / new files. Well, it's got backslashes in it. So it would think that that was C:\/ users ed files, you know. If you printed it out, that's what you'd see, because each /n would be treated like it was, you know, hitting the enter key. To prove that, let's go ahead and print this file name out. And I'm not asking you to make that change because that's a lot of typing to do, although I can show you how I got the path that quick. Alright, it's yelling at me. It doesn't know what one of these characters is. So in a language, in many, many languages, if you're specifying a file path, you have to do that. Or you use the other symbol. Unix, Linux, Mac OS. Make the slash go the other way, which is convenient for programs. So maybe this will work. Save to what file? golly.txt. Okay, I messed up. I didn't put a backslash before the word golly, so it's going to be saving it somewhere really weird. But if I look at the desktop, there should be a file named CIT1113b golly. Let's go look. Go to the desktop. Sort by details. Check the date modified, and there it is. Okay, I would like for us to play with that. Here's how I want you to get a path to write to. Open up Explorer, and our poor Mac user, I have no idea how to get the path as easily as we're going to do, so you can skip this part. What is that? Windows Media Player. We'll jam out while we do this. Okay, so let's just say that I want to save everything to the desktop. Go into Explorer, click Desktop, click in this bar up here, and it's not giving me the full path. Forget it, we're going to skip that. You know what the idea of a full path is now. It's like that. It says T:\, rather than C:, which is kind of odd. Network drives are usually things above the letter C. Floppy drives are usually, you know, A or B. CD-ROMs and DVDs and stuff like that are usually a little bit higher. So why that says T, I'm not quite sure. I haven't ever looked at this very carefully. Okay, I'm going to get rid of that part. We have saved to a file. Now we want to open that file for reading. Let's put a print statement saying done writing file, just so that we feel all good about it. So here's his or her explanation of a handle. A handle is somewhat like a TV remote control. Can you imagine explaining to somebody in the 50s what a TV remote control was? All right, we're all familiar with a remote control for a TV. We perform operations on the remote. The remote is not the television. All the real stuff is happening on the TV. The remote is just sending signals to it. It's a way of communicating with the TV. And the same with the handle. I don't know if that helps. Reading a file. To open a file for reading, it's the same syntax. You use the word open, but instead of W, you put an R there. And here are the programmers using a while true break. There are other ways of reading. We've used while true break a couple of times in the past. Who remembers an occurrence, a time when we've used while true break?
We do a password checker?
Yeah, that sounds right. anytime we did something like enter -1 to stop, we always did an if -1 then break. So anytime you're processing a sequence of data but you want to escape out from a while loop, you can use the break. And here what it's saying is, okay, I've got a new file. I want you to read some data from it. Whoops, if there wasn't any data in it because the length of the file is 0, that means that our read failed. We're at the end of the file. So break out of the loop. Once we break out of the loop, that means go to the next unindented line, which is that one, and we can close it. Okay. We've already got a file name. We could ask them for the new file, make them type it in. Let's do that, just to give ourselves more to type. Open what file for reading? File name is equal to input. That way we can cut and paste this code and have more likelihood that it would actually work. We don't really need that print file name line that I added up here, so I'm going to close that. I'm going to delete that. Alrighty. Now, my file, or I could call it something else, F, RF for read file, IF for input file, whatever. My file is equal to open, same kind of business. We have to say what file we want to get. But we're not opening it for writing, we're opening it for reading. And what does that mean? Well, when you open it for writing, you're either going to erase the file completely, like this does, or at the very least you're going to append data to the end. So it has to have special access to it. I'm sure that you've heard of read-only files. You Linux users may have typed in chmod space, in a certain series of numbers in order to mark a file as read-only, whatever. You could open a file that was read-only with this command, but if the file was read-only, this command would fail. And we need to figure out how to make this tell us that it couldn't open the file. We haven't done that yet. We're just blindly assuming, oh, hey, great, it worked. And we write some data out. So, we opened it for reading. It's a non-destructive access. It can't change it once you open it for reading. If it's a read-only file, that's totally cool. Let's do our while true. Let's get a line of data from the file. My file dot. This thing is almost useful. A lot of editors, when you type something dot, it'll bring up a list of all the possible commands. This one seems really cranky about whether it's going to do that or not. And if you try to select that line with the mouse, it doesn't work. You have to use your mouse. Anyways, some programming environments are a little bit better about that than this one. So what we want to do is we're going to read line into a variable so that we can do something with that variable. It's a string. It's a line. I could call it line is equal to myfile.readLine. It is a function, so we always have to end functions with the parentheses. Or I could do s is equal to myfile.readLine. Now let's print it out. Print. No, wait. First we better check to make sure we have some actual data. Nah, let's just print it out. If, no, what am I thinking? Print line is equal to, and let's put an open brace there. This is going to be a little bit different because we're not separating them with commas. We're separating them with pluses. And the reason we're doing that is so that it won't put spaces between everything. Like that. There are other ways to accomplish the same thing. All right. We're going to be bad programmers, and this is going to not work because we're going to run it right now just to see what it does. Okay, save to what I'm going to close this and rerun it. The problem we're going to encounter is that it never escapes this while true loop. There's no way out. There's no break statement. So it's either going to get some kind of error message or it's just going to loop forever until we kill the program. Save to what file? T dot what? T there. dot txt. Done writing file. Open what file for reading? I have an idea. Why don't we open t.txt? Ew. Okay, you see why we're going to put that break statement in? What we're going to do is say if the length of the line is 0. That just means that it read to the end of the file and there's nothing more to pick up. You've taken every box there is out of the truck. So, let's add that. If len of the line is equal to 0, break. Now, completely unindent, because now we're at the end of the loop, and let's close our file, like good little denizens of the programming world. myfile.close. Once more, t.txt. Open what file for reading? t.txt. All right, let's look at our output. I'm going to drag this over. I'm sorry if it closes the code. I'm not much liking this output. It looks weird. Does it look weird to you? Yeah. When we opened it, it was all nice and neat in a file, but now when we're printing it out, we're getting these extra line feeds. That's because hidden in this text file are line feeds. I don't know if you remember that site. I think we used text edit, 15 long weeks ago. Back when we still had hope. Let's see, open file, t.txt, and there we go. Once upon a midnight, well, it's not showing. Let's see if we can drag the window over. Okay. Maybe I can zoom it out. Oh, what do you know? Thank you. All right, I are a computer user. Okay, here we go. Dreary was the end of one line. And it's just showing a couple of dots here, but if we look over here, this is the ASCII for dreary, and then eventually we will find a 0D. That's ASCII for new line, or 0D, 0A. One means carriage return, and one means new line. It means new line. In Windows and DOS, they decided that you needed both of those to mark a new line. In Unix and a Mac, you only need one of those codes, either a 0D or a 0A. Windows supports that mechanism too, but if you pop open a file like that in Notepad, it'll show it all in one line of text. It doesn't know where the breaks are. So, anyways, what we see is that those special characters there are treated like a /n when it's read back out. So when we print it, it adds an extra line to everything we print.
So would we delete them?
That's what we're going to do. Fortunately, they give us a command to do that. What am I doing? It's called strip. You can strip either stuff on the left side. Why am I waving my right hand? This is your left. Why not? The left side or the right side or both. What it removes is not only new lines, but spaces and tabs. So let's strip this data before we print it out. Line equals line dot strip. Bless you.
Thank you.
Is this going to be the in-class?
Yes. Do I need to make the Dropbox? T.1. I'm not going to open it in Notepad, so I'm making it as easy to type as possible. T.1. Okay, that's much better. I'm liking that. Strip, however, will remove stuff from the beginning as well as the end. What do I mean by that? We had a file over here, Once Upon a Midnight Dreary. I'm going to go open that in Notepad, or find it in here. I think I called it t.txt. We're going to see what that looks like when we read it. So I'm going to run the program again and tell it to read that file. I don't want to override it, so I'm not going to write to t.txt, but I am going to read from it. It'd be a good idea to, present the user with a choice. Do you want to read or do you want to write? Let them pick one or two. Okay, so I'm going to write to some junk file. I just don't want to erase that t.txt, so I'm writing to t.1. Now open what file for reading? T.txt. It removed those tabs and indents and stuff like that, those spaces. So it did exactly what we wanted at the end, but it could be that you like those spaces and tabs at the beginning. In which case you don't want to just call strip because strip removes it from both sides. You also have rstrip, which removes it from the right, the beginning of the string, and you have lstrip, which removes it from the left of the string. So instead of making it strip, that sounds weird, let's do lstrip to remove it from the end of the string. Remove new lines and space from end of string. I love how when you put a comment there, it makes it look like that's the most important part of the program when it's really not. But we could add comments elsewhere, Open file for reading. This if statement down here is pretty important. Let's put a comment on this. If no data, that means end of file. Like that. Add a comment to read line. Get a line of data. All right. Now when I run it and I read t.txt, it'll still maintain the spaces that were. I guess. What have I done? All right, run again. Save to t.1, but read from t.txt. Oh. I put L because I've been gesticulating like this was L. See, being dyslexic, can confuse you. Should have been rstrip. Rstrip does it at the end of the line. Lstrip does it at the beginning. Because R is the, that side and L is that side. All right, so now it's got my tabbing. If you like the tabs, use rstrip. If you want to remove everything from it and just get pure data with no spaces at the beginning and no new lines at the end, just use strip. So that's opening a file for writing. That's opening a file for reading. We could even open our own file. Mine is called file1.py. So don't save to that file, you would erase it. But then read from it. Save to what file? T.1. Okay, open file1.py. Oh. I'm scared. It stopped there. It treated this blank line here. So this is a bad way of doing it because it stops at the first blank line. Let's see if that's true. I don't think it printed that what? Is this the end? Will we get here? The suspense. Killing me. Okay, so going to run it. T.1, T.txt. Open it up. It didn't get the /n. It stopped there. The reason why is because we started modifying the data before we checked the length. Once you remove all the spaces in the new lines and stuff like that, the length of it's going to be 0. So we don't want to strip it and print it before we do this check. We want to do it after. So we need to take these two lines and move them up between the line equals my file and the line equals our strip. Just cut those, paste them. I want that comment back up here. Okay, we're going to create a new file that's a new program that's going to read from a file. This file is going to contain a series of numbers, and we're going to add all those numbers up. Yes, sir. You need it? Alrighty. So make a new script, new file, save as, call it file 2. My name, date. This program opens a file, reads each line, adds up all the numbers that are stored in it. That is assuming that the file is a list of numbers, you know. If it's not, then this program's going to crash. So let's ask the user for a file name to open. Print. Read from what file name? File name is equal to input. Now I want to open that file. File is equal to, and how did we open for reading? What was our function call for reading from a file? Our syntax for opening it. It was OPEN, and then what was inside the parentheses? Yeah, we need the file name. It was t.txt until we changed it to using the file name. And then we're reading from it, so what letter are we going to put? An R, right. Now, do we want to store all this data in a list and then add it up, or do we just want to add it up while we're reading it? I think that we ought to put it in a list. So let's make an empty list. L is equal to blah, squares, empty list. Now we need our loop. While true, get a line of data. S is equal to, S standing for string, I could have called it line. I could call it N for number. File or dot read line. Now let's check its length. If the len of S is equal to 0, we better break out. Okay, we need to trim it. Strip it, excuse me, trim's another language. So S is equal to S dot strip. Since it's just supposed to be a number, I don't mind removing the spaces from the beginning and the end. All right, now how do we turn that S into a number to add? This is just like the user typed in a number using the input. What did we always do whenever we let them type in a number? Yeah, let's change it to a float. S is equal to float S. Let's add it to our list. Append. L dot append S. Why am I putting a blank line between everything? I'm not sure. Seemed like we had more layers, you know, more tabs in the other one, so I'm wondering if I'm doing something wrong. Once we get done with all that, we need to close the file. File.close. Now just to make sure this worked, let's print the list. But we're not going to take any time to do a for each, a for loop to print it. We're just going to print the list like that, all in one line. Now I'm going to run it, and I don't know, maybe I'll read from t.txt. It doesn't have any numbers. This is not going to be good. t.txt, it blows up. Okay. I closed my file. Open file to, all right, let's run it again. Read from what file name? Maybe I'm going to call it numbers.txt. No such file or directory. So we got an error when we tried to open that file for reading because it doesn't exist. And we haven't talked about the mechanism that would be used to correct that. So we're just going to live with that for now. Take scripting. Okay, so let's make a file called numbers and put some numbers in it. So go over there into your search box, type Notepad. Just type in like 4, 5, 6 numbers all in a row. And then do a save as and save it into the same directory as your py scripts. And call it numbers.txt, or call it anything you want, but just make sure that that's what you open. All right, I'm going to remove the blank lines now. They're bothering me. I shouldn't do that until I make sure everybody's gotten this working. It'll be about time to wander around, go walk about, make sure people got it working. Read from what file name? Nope, not t.txt. Numbers.txt. And there they are. We could do all sorts of cool stuff with that, you know. Really cool stuff like sum them and average them. Kind of things we live for.